Hello everyone, welcome to another video. This is part 5 of my Gateway API on Kubernetes series, and this is going to be one of the most exciting videos of the series. Today I want to show you how you can deploy and configure the Cert-Manager and then use the Cert-Manager and cluster issue to automatically create TLS certificates. All of this is free and it will take only a couple minutes to implement. And once it's set up, we can automatically create TLS certificates and therefore access our applications using HTTPS. So the plan for today is, first I'm going to give you a quick overview of what we have built so far, the architecture and the components. I will also link here the playlist down below so you can take a look at the previous videos where I go through the setup step by step. Then I'm going to show you or explain to you what the cluster issue and the Cert-Manager is. We're also going to deploy one. And in the end, we're going to test if we can access our applications using HTTPS. As always, if you're interested in all the demos I'm showing you today, you can scan the QR code or you will find the link in the description down below. Now, before we get started, let's have a quick recap of what we've done so far. So here you can see we have created a Kubernetes cluster. In my case, I'm using Azure Kubernetes Service. Then we've created on top here this application gateway for a container. This will take off the load of our cluster because it does operations like TLS termination outside the cluster. Then it redirects or forwards the request to our cluster. There will have a component, the so-called gateway. Now let's take a look at what we're going to do today. So here we can see we leave everything as it is, but additionally, we're also going to create the Cert-Manager, and then we configure the Cert-Manager to use Let's Encrypt to create TLS certificates. In the end, you will see these are completely valid certificates, so nothing like developer certificates where you still get an error message or a warning. It will work like any other website you see on the internet. The way it works is we have the Cert-Manager that's configured to use Let's Encrypt. Then we also have a component called Cluster Issuer. As the name suggests, it issues the TLS certificates through the Cert-Manager. And then we also have again our gateway inside the cluster, and we will configure our gateway that it knows where we store the certificate. So for example, here in the blue box, we can have a certificate and we have a link to the gateway. So if we call our website using HTTPS, the gateway can check with the certificate if it's a valid request. Your browser will also show that it's a valid request, and then we can forward our request to our pod and then serve the content. Before we implement all of this, let's have a quick look at the Let's Encrypt certificates. So what's amazing about Let's Encrypt is you can use them. You don't have to pay anything. You don't have many limitations, and they're completely valid on the browser. So you won't get an error message or a warning, and it just works and it can be used. One of the attributes of Let's Encrypt certificates is that they're valid for 90 days. If you use to install certificates by hand, this may sound very counterproductive because installing certificates can be quite a pain and you want to do it as few times a year or even a decade as possible. But it's safer to have shorter lifespans for the certificates, and since everything is automated, they are restricted to 90 days. With the setup we are going to configure today, the Cert-Manager, the certificates will be updated or renewed automatically around 30 days before they expire. So we don't have to worry that from now on we have to update certificates all the time. Everything will be handled inside our Kubernetes cluster. Seems like I was a bit too slow moving forward my presentation. I just mentioned this, that it will be updated automatically. You will also get an email when it's updated, so you'll also know what's going on. Also, I said the certificates are free, which is true, but you can also pay for some additional features. But for this demo, I want to keep it free, and you will see it works perfectly fine. With this said, now let's switch over to the terminal and let's get started installing everything we need. Alright, here in the terminal, let's define a couple variables as always. So these are a couple variables for our cluster. First, we have the namespace where we deployed our gateway, the name of the gateway, the name of the gateway class. Since I'm using the Azure Application Gateway for Container, I use the Azure ALB external class, but you can use any gateway class you want if you implement it yourself. Then I provide the name of our application load balancer and the name of the cluster issuer we're going to use later. Then I'm going to configure a couple variables for our applications. So in the, I think, third video, I deployed an Nginx and one traffic, but we only used HTTP there. Now I'm going to update this so we can use HTTPS. And here provide just all the information I need about the application, like in what namespace I've deployed it, how I want to name the certificate, and what the URL to our Nginx application will be. Also the same for our traffic application. So it's just the namespace where I've deployed it, and again, the name of the application, the name of the certificate I want to create, and also the URL. Once we've defined the variables, we can already install our Cert-Manager, and we're using Helm to do this. So first I'm going to add the Helm repo and also make an update just to be sure that I have the newest version, and then we're going to install it. So let me execute this and then we take a look at what we're doing here. So it's just a normal Helm install. We provide the name of the Cert-Manager. I deploy it in its own namespace called Cert-Manager. I also create this namespace during the deployment. You could deploy it in the infrastructure namespace, but I like to separate my objects a little bit so it's easier to manage them. Then we provide the version. That's the newest as of recording this video. And the last one that's important here is the config. We configure it to use the enable gateway API to true. This means that the Cert-Manager is now aware that we are going to have a gateway. It should only take a couple seconds and then the Cert-Manager is deployed. The Cert-Manager takes care of creating the certificate, but it needs a second resource. That's the so-called cluster issuer. And the cluster issuer has the configuration to the organization or API where you get the certificates from. So let me paste the configuration and then I take a look at it. So here you can see we have our cluster issuer. That's a Kubernetes type. Then it doesn't matter where you deploy it. As you can see here, I'm not deploying it in the Cert-Manager namespace. I deploy it in the infrastructure namespace. You don't have to do this. I just do it so you can see that you can spread it out. You don't have to use the same namespace. Then we configure the server or the endpoint where we get our certificates from. In this case, I'm using Let's Encrypt. And here you can see there are two servers configured. Kind of configured because the second one is commented out. But I left this in because this is the staging endpoint. And there are two differences between the production and the staging endpoint. The production endpoint has a limit of 5 certificates per URL per week. So if you get started testing and recreate everything a couple times, then you might run into this limit quite quickly. The staging server has a way higher limit, so you won't run into this. The problem is that the browser will give you a warning if you use the staging server. So it's not a fully valid certificate, but for testing and setting everything up, it's good enough. Since I've already tested it in the past, I use the production server and you will see how everything works. Next, we're going to configure our email address. This email address will be used for notifications. For example, if your certificate is updated automatically, you will get an email. Lastly, we have here the solver, and this is very TLS specific. So if you don't know how TLS works, it might become a bit complicated. But the way in this case, how it works is we tell Let's Encrypt we want a certificate for our URLs. So in my case, I've configured in the variables before nginx.programmingwithwolfgang.com. But I also have to prove that I own this URL. I just can't create certificates for any URL. And this is what this HTTP 01 request does. So in this case, Let's Encrypt puts a file into a well-known folder or address, and then Let's Encrypt checks this folder. Since I own the URL, it will go to my cluster into the folder where I have put the file. And this way I can prove that I own this URL. What's important is this does not work for wildcard certificates. So if I have *.programmingwithwolfgang.com, this won't work because this is not secure. In my next video, I'm going to show you how we can update the cluster issuer so we can use also wildcard certificates. But for now, we just use specific certificates. So what we configure here is basically just the HTTP route. There we say what type we have. Here again, we're using a gateway, therefore we say gateway. Then we provide the name of the gateway and in what namespace we have deployed it. Then I'm going to save this in this variable and I'm going to apply this. So if you're using, for example, bash, then you will have to change this from this @ sign to end of file. But I think this is the easiest way for me to show you the demo. Another option would be to use separate files and then do a kubectl apply with the file. But then I would have to switch around between the editor and the terminal. And I think it is easier this way, but let me know in the comments what you prefer so I can change it in the future. So while I talked, the cluster issuer has been installed. So now we can take a look at kubectl get cluster issuer and I get all the cluster issuers. I don't have to provide a namespace, but since I only have one, we can see here we have our information. What is important here is that the status is true and the type is ready. We can also see here the Acme account was registered with the Acme server. So we didn't get any error message and nothing indicates that something went wrong. So this is great. Now we can already get started creating our certificates and then test our applications. Next, we're going to create the certificate for our traffic application. So here we have the object of certificate. Then we provide a name and a namespace where we want to save this. And since I think the certificates belong to my infrastructure and gateway, I also want to have it in the same namespace as we can see here. In theory, you can use any namespace, but if it's not in the same namespace as the gateway, you also have to have a so-called reference grant. And this will configure Kubernetes that the gateway from the different namespace is allowed to access the secret. So for now, I would recommend to keep it as simple as possible and store it in the same namespace as your gateway. Then we provide some basic information like the name of the secret we want to create. This secret will contain the information about the certificate. Then we say that our issuer is a cluster issuer and we provide the name. The probably most important configuration is this DNS name. That's the URL we want to create the certificate for. So in this case, it's traffic.programmingwithwolfgang.com. Let's save this in the variable and then we can apply it. So now the challenge is happening. So if we are quick enough, we can also take a look at the TLS challenge. So we can do a kubectl get challenges. And there you can see something is happening. Here we have waiting for the HTTP 01 challenge propagation. And this is exactly what I said before. Now the Cert-Manager and cluster issuer create this specific file. That's usually a TXT file. It puts it in a well-known place. And then Let's Encrypt will check this place. And if it is there, then Let's Encrypt knows I own the URL and will give me my certificate. This takes usually around 30 seconds. So if we clean this up, then we can now take a look at our certificate. So we do a kubectl get certificate. We provide the name we've just given it and the namespace we have deployed it in. Here you can see we have the certificate, and what is important is that this ready status is set to true. If the challenge is still going on, then it will be false. And also if you have misconfigured something or something went wrong, it will also stay false. For example, if you waited a couple minutes, it's still false, then it means something went wrong. This could be, as I said, for example, I ran during preparing this video into the limit of the 5 creations per week, so it always stayed false and I had to change my URL to test it further. But here you can see everything went well, so this is true. Now we can also create the certificate for our second application. This is basically the same. It's again the type certificate, again the namespace of the infrastructure, the same cluster issuer, and this time we use the URL for Nginx. This is nginx.programmingwithwolfgang.com. So you can also save this in the variable, we apply it, and now exactly the same thing as before happens. The Cert-Manager and cluster issuer put the file into the well-known place. Let's Encrypt checks it, and then we will get our certificate. As I said before, it will take around 30 seconds, and here you can see we waited for 17 seconds so far, and the status is false. So now we have to wait a couple of seconds longer, and then it should be there. So if we check again, now it's already true. This means we just created our TLS certificate. As a next step, we also have to update our gateway so it knows about the certificate. And we also have to add a new listener. So we are listening on port 443 for HTTPS. So far, we were only listening on port 80, HTTP, and therefore we have to update our gateway. So let me paste the entire gateway configuration and then we take a look at it. So it's quite a lot of text, but actually once you got used to it, it's quite simple to understand. So everything you can see here is what we already had before. We have the type of gateway. We have some basic information. For example, for Azure, the load balancer, namespace and name. What is new here actually, what I forgot, is we tell it the name of the cluster issuer. Then we have here our listener for port 80. So this also. And now we have here our listener for our traffic. All this. We have to provide a unique name. In this case, traffic HTTPS listener. Then the port is 443 and protocol HTTPS. The host name, that's the URL we configured in the certificate. This is traffic.programmingwithwolfgang.com. And here under TLS, we tell it in what secret we have stored the certificate. So this is the same name as before and also the same namespace. If you scroll further down, we can see we have another listener on port 443. And this works because it has different names and it also has different host names. So here we can see we have our host name for Nginx. This is nginx.programmingwithwolfgang.com. And we also have here the different reference for the secret. In this case, you have the Nginx secret referenced. Now let's apply this file. Then we wait a couple seconds because it takes around 5 seconds usually to create the listener and to update the gateway. And while I'm talking here, we can also paste the next command, the kubectl get gateway. We provide the name of the gateway and the namespace. And here you can see that we already have here our Nginx HTTPS listener, and further up somewhere we have the traffic one. Also, we can see here the status is true, the type is programmed. We can see also here the resource has been successfully updated. So again, nothing indicates that something didn't work, no error messages. So everything seems to be great. To make sure that everything is great, we can now test it. And in theory, if you followed all my videos, you don't have to update anything because we already configured the host name the last time we configured the HTTP route. But in case you haven't seen it, the way gateways work is we have the gateway, then we have an HTTP route, and this HTTP route configures what is forwarded to which service. For example, if we have traffic.programming.com, it should be forwarded to the service with the name traffic. I'm going to paste the HTTP route for traffic in this case. We can also see here the type is HTTP route. Then we have the reference to our gateway, the name and the namespace. We have here the host name. So again, that's traffic.programming.com. And down here, we have the rules where we want to forward the request. In this case, it's a service called traffic and is listening on port 80. If you're new to all of this, I would highly encourage you to check out my previous videos in the playlist because I'll go through it step by step and explain everything how it works. One last thing about this, we can see also here under the rules, we don't have any rules. We just forward everything to traffic. In one of the following videos, we're going to take a look how we can have more complicated routing rules. So we can have, for example, canary deployments, A/B testing, we can route based on our path and so on. But for now, we just keep it as simple as possible and we forward everything from the traffic URL to the traffic backend. So we're going to apply this HTTP route and now it would already work. But I also want to test the same thing for Nginx. So I'm going to apply basically the same HTTP route, except I change the variables to Nginx. So here we have the host name Nginx and we forward it to the Nginx backend. We're also going to save this in the variable and we apply this HTTP route. And now we can switch over to the browser and hopefully, if everything went as expected or as we hope, then we'll see we can access our applications with HTTPS and we won't get any error messages. So let's switch over the browser and let's get testing. Here in the browser, let's first test nginx.programming.com. We can see we have our welcome page. We can also see we didn't get a warning that our page is insecure. If we open this here in Chrome, we can see the connection is secure. If we click on it, we can also see the certificate is valid. If we open this, we can see it's from Let's Encrypt, it's from my URL, and it will expire in 90 days. So around middle of January 26. Great, everything worked as we hoped. Now let's also test traffic, but there I expect the same behavior. So let's type traffic. And also here we can see we have our traffic and we also have here a valid certificate. The connection is secure. And everything, once it's set up, will be done automatically. This is everything I want to show you today. So we have seen it is very easy and only takes around, I don't know, maybe 20 minutes to install the cluster issuer, the Cert-Manager. Then we created a new certificate and we also told our gateway to listen on port 443 for HTTPS and what secret it should use. Then we updated our HTTP route. We added our URL and hostname to the route. And now we can access our applications with our domain with HTTPS. In the next video, I'm going to show you how we can extend this so we can also use wildcard certificates. This is currently not possible because we have to update the cluster issuer and we also have to integrate it with our DNS. This is due to security reasons because Let's Encrypt has to check the DNS for the wildcard certificate. But I will show you in the next video everything step by step how we can set it up. And then in the following video, we are going to combine everything we have done so far. This means I'm going to show you how we can create a pull request, in my case in Azure DevOps, but it will work the same way in GitHub, GitLab, whatever you're using. and we're going to deploy our application during this pull request into our Kubernetes cluster. We're going to create a certificate, and we're going to create a new URL. And all of this will be done automatically. So for me, these are the most exciting parts of the video series, even though I have more videos afterwards. But I hope it's for you as exciting as for me, because it is so easy to set up. It makes our life so much easier and also keeps our application secure. With this, I'm looking very much forward to the next video, and I hope to see you there again.